All right, let's get started. Is this thing working? Seems to be working. Okay, so this is the 11th week of the semester, so it's 2/3 over. And we're sort of on the home stretch. PS9 is out. It involves recursion. And then at the end of the week, PS10 will come out. It will be a graphical user interface. And then we're to the final project, which will come out right before Thanksgiving and be due at the end of the semester. We'll have a lot more to say about that later. Are there any questions or problems before I go on? One thing I've been asked several times, people are buying new computers and they go to install Java and notice that JDK 10 is no longer supported. That's sort of a new thing. Java used to, the people that provide Java used to support old releases, and they quit that after JDK 8. So you'll need to install JDK 11. It shouldn't cause any problems if the TAs, the TAs may notice that you're using a version that's incompatible, but they can make a simple adjustment and then it is compatible. So I guess this is more for the TAs than for the students. But JDK 11 will be okay. All right, now on the assignment you're doing, it could be the easiest assignment all semester, or it could be the hardest assignment all semester. It just depends on whether you understand recursion or not. And clearly, I prefer it if all of you thought it was the easiest assignment all semester. There are two parts of it. Forgot to do that. One part involves writing methods dealing with a mobile, like I talked about last time, basically a binary tree. And the other part involves dealing with files and folders, like I talked about at the end last time. So I want to talk a little bit more about that. But I forgot to set up my screen here, so bear with me for a second. Okay, so we looked at this last time. So remember, to Java, a file is either a folder or a document. So this takes either a folder or a document and computes the number of documents that it contains. So if it is a document, if F is in fact a document, we return 1. So this is file method is essentially telling you, is F a document, despite the name. Otherwise, we're dealing with a folder. Yeah?
So are there only two things in the file system? One is called document and one is called folder?
You're asking why am I using the words document and folder?
No, I mean that are there only two type of things in the file system? One is folder, one is document?
Yeah, so, okay, so what he's asking, he's asking, are there only two kinds of things in the file system, folders and documents? There are some other things like symbolic links that we're ignoring, and I'll have something to say about that in a second. That's all we care about are folders and documents. Yeah?
So can I just distinguish the document and the folder by is file and is, I think is dictionary?
Okay, so there's an is file method,
Yeah.
there's an is directory method. That'll tell you, is file tells you if it's a document, is directory tells you if it's a folder. Now, if F turns out to be a folder, what we saw last time is that what we were trying to do is add up all the documents that the folder contains. Of course, the folder may contain folders, which contain folders, which contain folders, which contain documents. So what this loop does right here is it goes through everything contained by the folder. And for each one, it counts documents, adds them into the total. And then in the end, we return a total. Now, that worked just fine until I tried to run it on my entire file system on C:/. And when I did that, I got a null pointer exception. So I fixed that, so I'm going to run this. It'll take a while, but So this is going to count all the documents on my hard drive. And I'll let it run while I'm talking here. Okay, and what I discovered after class, which is what I discover every year and forget, is that sometimes if you take F and ask it to list the files it contains, it returns null. Instead of it's supposed to return an array of files. So there's some sort of thing in the file system, I haven't figured out what it is, which is neither a file nor a folder, really. And so I wrote the code to pull everything that the folder contains, but ignore it if it gets null back. So we ignore those things that return null when you ask what files it contains. So I added this code right here after class. So I put this if in so that if F happens to be one of those weird things, we just return 0. I really should investigate more and see what the weird thing is. Okay? So that's what it amounts to is an accumulation loop that makes a recursive call inside to find the size of each. Oops, I'm on the wrong one. To find the number of documents contained in each piece of each thing contained in F. And the method you're writing on the problem set will look a lot like this. And you can see it's still trying to count all the files on my computer. But let's do one more here. Longest file name. There we go. So 476,283. Yeah?
So what's the largest? Is that just like the file size?
Yeah, that's the file, that's the size of the largest file.
In bytes?
In bytes. So let's see, that's about 64 megabytes. But not on my computer. When I ran that, I ran it just on my workspace. So that's the largest file on my workspace. This is the number of documents on the computer. Okay, let's find the name of the file that has the longest name. Okay? And the pattern, I'm going to copy the pattern from up here. The pattern will be very similar. And I'll paste it in. So so we're asking to find the longest file name of any of the files in this piece of the file system F. Now if F happens to be a document, what is the name of the longest file? Right? It'd be the name of the file, right? Whatever F's name is. So you just do F dot get name and return that. But if it's a folder, we got to go searching recursively through the file system to find the file with the largest name. I think my spec said the document with the longest name, so I'm not going to look at the names of the folders. So what kind of loop am I going to write if I'm looking for the file, the document with the longest name? Yeah?
Optimization.
That's an optimization loop. I'm looking for the longest file name. So I want to write an optimization loop. This happens to be an accumulation loop. So maybe I should come up here, which is where I got up here was an optimization loop. So let's replace that so we at least got an optimization loop here. Okay? And what we need to do is fix this up so that what it does is return the longest file name that it finds. So I want you to work on this for a little bit. Look at that. This is very similar to the kind of assignments things you'll do on the assignment. So talk to the people around you. What needs to change? What doesn't need to change? This is an optimization loop. It's looking for a long, so clearly that has to change. Okay? You can say, oh, I don't understand this, and just sit out the next 5 minutes. But then you're still not going to understand it when you do the assignment. So even if you don't understand what's going on, talk to people around you. Maybe someone around you does that. Right, let me just interrupt you for a second. What should our variable be? Okay? Clearly it shouldn't be a long. What type of variable should we have here for our accumulation loop? Okay, string, because that's what we got to return. And what would be a better name for it than largest size so far?
Longest name so far.
Yeah, longest. Okay, and the specification says that if you don't find any documents, which would happen if all you have are empty folders, you're supposed to return the empty string. So that makes sense as an initial value. So if we don't find anything longer than the empty string, we're supposed to return the empty string. That works out nicely. All right, so go back to work and think about what has to happen inside, really inside this loop. Okay, let me see what you got here. So this is our optimization variable, empty string. We find out what get the files contained by this folder. Make sure it's not null. If it's not null, we iterate through. So what do we do for each file G? You could tell me what we should do for each file G. Yeah. Okay, so you're saying we should look at g.getName?
Oh, that was yes.
Okay. So what should we put here? So maybe you're saying not to put that there. So you want to say if g.getName.length is greater than longest name so far.length. Then okay, that may have been what you're suggesting, maybe not. Okay, so look at this. So for every file we go through, we say, we're iterating through everything that F contains. So each time through the loop we get a different G. We look at its length and compare that to the length of the longest name so far, and if we got a new winner, then we get that. You remember it, and then when we're done, we have the longest name so far. What do you think? Does this work or not? Yeah, I heard a no. Who said no and is willing to explain why not? Yeah?
Well, it's not really recursive now, because it's not calling itself again. So it would just look in the first subdirectory that passed the first statement.
Okay.
And it would just start checking those statements in that file, those files.
Right, so what he said was there's a red flag here. This is not recursive. So that means if I give you a folder, I'm going to look only at the things the folder contains directly. If the folder contains a folder, I'm not looking inside that folder. I'm just looking at the names of everything directly included in the folder. So what I need to do is for each G, what do I need to do? Yeah?
Set a variable name and then all longest file name.
Right. What I need to do is make a recursive call, not to that method, but to this one. I want to find out the longest file name contained anywhere inside of G. So I'll make a recursive call to do that. And I get a string back. So the string I get back is going to be the champion of G, the name of the longest file contained by G. Now if that is longer than my current champion, then I do that. So I need to say if name.length is greater than longest name so far.length, then I get that. So you'll notice that you're going to have, inside this for loop, you're always going to have a recursive call. And we get it there, we get it here, we get it there. Yes?
And that was a recursive call because it was using the method name inside of it?
Right, I'm calling the method right here. Because I need to find the longest file name contained anywhere in G, no matter how deeply nested. And we have a method right here that'll do that. So we call it. And don't over-mystify recursion. In the second week of class, or third week, probably not second week, but maybe in your third assignment, you wrote optimization loops. Optimization loops which we're calling methods inside of them. The only difference here is the method call is recursive. Other than that, we could have done this in the third week. Third assignment. Okay? So just like all optimization loops end up looking pretty much the same. All of these, you're going to implement 3 methods on the assignment for files. They all end up looking the same. There's a base case if the thing is a document, and there's a recursive case that involves looping through everything a folder contains. And there will be a loop over everything the folder contains, and there'll be a recursive call inside that solves it for a sub-piece of the file system. So if we run this now, comment out this guy. That's the longest file I found. Longest file name, I should say. Okay, any questions I can answer about PS9 or recursion or files or? Yeah?
I have a question. Since most of the methods, since the methods in PS9 can be written as one line, how does that account for the base case called recursion? Does that make sense?
It doesn't. So
When you call
I guess a better way to put it was each of your methods is going to be an if else for the base case and the recursive case. The base case can be written in one line, the recursive case can be written in one line. I think maybe I used to do the problem slightly differently, and you really could do it in one line, but yeah. So the pieces of the condition we can do in one line. I'll go back and fix that. Yeah?
What? What in the string longest file name, and it's different here, what do we put for f.is file? Because it's got to be something different from 0, but a blank space doesn't seem to work.
Which method are you talking about?
Oh. No, the next one. Longest file name.
Mm-hmm.
Okay, so you return f.getName. And f.is file, that means it's a folder, right?
If f.is file passes, then we got a document. Is file will tell you if it's a document.
Well then, but then, I thought that else was what happened if you got a document.
No, Okay, so the else tells you it's a folder.
Oh,
That's why we're able to loop through the files the folder contains. Yes?
So I'm just kind of confused on how the recursion kind of works. I mean, like, what does calling a method again inside of the method actually do?
Okay, so he's asking, what does calling a method from inside the method do? Well, what does calling a method do?
It just takes you inside of the method, I guess? Or
Why do you call a method? Why do you call square root method? If you're writing a program, why would you call a square root method? To calculate a square root. Okay? Why would you call longest file name of G?
find the longest file.
To find the name of the longest file that G contains. So you make a recursive call for the same reason you make a non-recursive call, because you have some problem you want to solve, some subproblem you want to solve.
So it's kind of like you need to write the method to solve how to do the method. Like, I don't know.
Well, think about this, the problem. You've got a folder and you want to know the longest file, the name of the longest file that's contained anywhere in that folder, no matter how deep. Well, to do that, you've got to take each thing the folder contains and find out what's the name of the longest file this chunk contains. What's the name of the longest file this chunk contains, and put that information together. But solving those subproblems, you need to call a method to do it. And it just so happens that it's a recursive call. So if your data contains within it smaller pieces of data that are structured just like the larger piece, right? Like mobiles or file systems, you're going to typically have recursion. Yeah?
I thought you said we were going to have to do some ad hoc recursion, and it doesn't seem like there is any in the...
Right, so I promised a Minesweeper game, and we sort of ran out of time on that, so you may see it this week instead. You got a question back there? Say it, yeah, talk louder. What about the project list? You're going to have to talk like twice as loud.
The Minesweeper, it's in there, project list.
Yeah, it's in there. But it's not on your computer, it's just on mine. It's definitely. There's a difference between having a program and having an assignment. That's what I ran out of time on, was turning the program into an assignment. Anything else? Okay. So when I think about the class, I think there are three main topics. The class roughly splits into thirds. So the first part of the class, we're talking sort of about traditional procedural programming. Static methods, loops, conditionals, assignments, variables, that sort of thing. Second part of the class, we talk about, I should say the second part of the course, we talk about classes, implementing classes. And in the third part, we talk about polymorphism. That's what we're going to start today. So this is our last major topic. This is a topic that did not exist at all when I learned the program. And the previous topic about implementing classes existed, but in a very different form. So polymorphism, I think it's from the Greek. It looks Greek, not Latin. But anyway, poly means many, and morph means shape or form, and ism means the practice of. So polymorphism is the practice of creating program components that can take many forms. So let's look at some examples. There are three forms of polymorphism I'm going to talk about that show up in Java. First of all, they're generics. And another word for that is parametric polymorphism. Then there's inheritance, which is an example of subtype polymorphism. And there are interfaces, which is another example of subtype polymorphism. So we'll talk about generics and inheritance and interfaces. Now, you are already familiar with generics. You've been using them most of the semester. So you can see here, imagine a language. When I talk about generics, what I mean are class names that have additional information in angle brackets after them. So you can define array list of string, or array list of integer, or array list of big rat. You can use any of those classes, but there's really only one class in the library, array list of t, where t is any type, any. Okay? Now, if you didn't have this in the language, what would you have to do? What if you did not have generics? Yeah?
You want to write a method for each parameter to specify each specific one.
Okay. So, paraphrasing what he said, if I wanted an array list of strings, I would have to create a class called string array list or something. And then I have to create a class called integer array list and a class called big rat array list. Now, if I wrote all those classes, array list of this, array list of that, how similar would they be? How much does an array list care about what it contains? Not really at all. It just knows it contains something. And so the code for these classes here would be virtually identical. It just, and what you would do, suppose these three classes existed and someone says, okay, now create me a double array list class. What would you do? You'd copy the code of one, and you could almost just go through, probably could, just replace everywhere string showed up. Or let's take big rat. Everywhere big rat shows up, you just replace it, do a global replace, and replace it with double. And that would probably be good enough. So it'd be kind of boring form of programming. And so people recognize that after a while and created generics. So basically, when you write a generic array list, everywhere the type of the, you need to declare the type of the thing that this contains. You just use t or some other letter that you pick. It's a parameter name. And then when you use an array list of string, the compiler goes through and replaces every occurrence of that t with string. So it's pretty simple. Yeah?
So does T have a type, or is it just telling
No,
the compiler?
T doesn't have a type. T stands for a class.
Okay.
So T, you can replace, what that means, in the case of an array list, you can replace T with any class. Yeah?
And that's why you can't use primitives like in an array list?
That's, yeah, and the reason you can't say array list of little I and T is that T has to be a class, in Java anyway. Yeah?
If you wanted to restrict T to be a certain subset of classes, is there a way to do that?
Okay, so he's saying maybe sometime you won't, for example, a tree map, a tree set. The things that go into a tree set, you can't put any old object into a tree set. It has to be things that can be compared to each other. Because remember, the tree set produces things in order. So yes, there is a way of putting restrictions on that class parameter T. So you can say, you can only instantiate tree sets with things that can be compared to each other. Okay? So, on the one hand, generics are easy. On the other hand, that's all I'm going to say about them. You take 2420, you can learn, or if you just read a little bit, it's really not hard to implement generics. That's a topic I leave till 2420. Let someone else do it. Just for completeness here, this is just reminding you that generic classes can only be instantiated with classes, not with primitives. And so that's what we've talked about wrappers before. So if you want an array list of little ints, you've got to create an array list of big integers, which are just objects that contain ints. So I won't dwell on that, because we've talked about that enough. So that's one form of generics. Now, here's ones we'll actually talk about in depth. Inheritance. So, a class D can inherit from another class B like this. So you're used to saying public class D, and then you give the definition here where the dots are. You can say class D extends B. So D extends B. And I used B and D because the class being extended is called the base class. And the class that's doing the extending, the class we're defining, is called the derived class. So I use B and D for base and derived. So D is inheriting from B. So I want to explore what that means. So we're talking about inheritance now, and you know you're using inheritance when you see that extends keyword. Okay, first thing to know. So a D object contains the instance variables of B as well as the instance variables of D. So look right here, this is a B object. Remember, B is the base object, the thing being inherited from. Suppose the B object contains an age instance variable and a name instance variable. So you know that every B object will have those two values in it, an int and a string. You create a million B objects, you'll have a million objects that contain these two things. So you're used to that. A D object, suppose you declare the D object, you declare an instance variable in here, the way you normally do. So yes, every D object will contain that instance variable right there, but it will also contain the instance variables defined in B. So one thing that happens when you inherit is you're inheriting the instance variables. The new object will contain all the instance variables declared in the derived, in the base class, as well as any declared in the, okay, it gets the ones from the base class as well as the ones from the derived class. Okay? However, the code you write in D cannot access these things. They're there in each object, but any code you write in D can't see them. Well, yeah, we can talk about why they're there, but the rule is you can't directly access age and name if they're declared private. Yeah?
Is there a limit on how many like objects you can inherit from each other? So like, can you just keep going on like?
Okay. So yes, you could have a class X, and then you could have Y extends X, and Z extends Y, and W extends Z, and then W would contain the instance variables from that entire chain.
They can just keep on going.
Yeah, there's no limit. Now, why do you think that a D object needs to contain instance variables that that its code can't access? Why would an object need to, why would you carry around those yellow instance variables? If nothing you put into the D class can access those instance variables, what's the point? Yeah.
So that other methods that it can, so the methods that can get the values of those, they can still access it, but
Okay.
it doesn't need to. Right?
So other methods can access those instance variables. And the ones that can are the ones that you inherit. So the point of inheritance is, suppose, here's the B object again. Let's look at the instance variable, not the instance variables, the methods it defines. So let's say it has a private method called F, a public method called G, and a public method called H. That's in the base class. The derived class will inherit the non-private, so we don't inherit the private F. But D will contain a G method and an H method by inheritance. So when you inherit from another class, you inherit its non-private methods. So when you inherit, you're saying, I want the class just like this old class, but with some differences. So that means that a D object, if you hit dot in Eclipse, it'll say there is a G method that you could run on that object, there's an H method you could run, and maybe we've defined a new method called print. It's just in D. So these yellow methods are going to have to access the instance variables, the yellow instance variables. So those yellow instance variables are there so the inherited methods can work. Got a question over there?
Yeah, so what if you had like a private helper method and that method wasn't inherited and then it would cause other methods to like malfunction? How would
Okay.
you get around that?
So let me paraphrase what he said. Suppose that over here, G calls F. Then you inherit G, but you don't inherit F. What's G going to do when it tries to call F? The answer is it'll work. It's able to call F. Because G has access to F. When I say that D doesn't contain F, what I mean is you can't invoke F on a D object.
But you can invoke F in a method.
A method you inherited. Print could not invoke F because it's private. But G and H, which you inherited, they can still access F. So they're there, the private methods are there so that G and H can work. But you can't use F from the code in the class you're creating directly. Yeah?
Would G in the object also be able to access these private instance variables?
Yes, G and H would be able to access these private instance variables. And that's why we carry them along in every D object, so that our inherited methods have something to work on. Okay? Now, at this point, you may be thinking, you know, this is like Alice down the rabbit hole, and you don't see the point of this. What I'm going to do is, I'm going to introduce you to the high-level ideas of inheritance. Then we'll actually see it in action, and you'll see why it's useful. It'll make more sense when you see some code. But first, I just want to sort of set the scene. So you inherit methods. Now, the other thing is, you can, if you're implementing D, you can override things you inherited. So D extends B, so we inherit G and H. We implement a print inside the D object, and then we implement G inside the D class. Then we implement G inside the D class, and this G is replaced by that G. So we still have a G method, but it's a different one. So when you inherit, you get all the methods from the base class, and then you can replace the ones that you want to replace. You can replace implementations. Yeah?
Do you have to use @override with that, or is it just...
Well, okay, so he's asking a syntactic detail. I want to put that off to later. Short answer is no, it's optional. But we'll talk about what it looks like in code later. Now, it turns out that there is a way to refer to the G that just got overridden. From inside of D, you can refer to the original G as super.g. Yeah?
So it can only be overridden if it's an instance variable that was inherited.
No, you don't override instance variables. You override methods. Right. So you override inherited methods. Now, before I go on, I want to point something out. You have all been using inheritance in every class that you've ever written, because every class has to inherit from some other class. You do not have a choice. Now, you may have never written extends and then a class name. The rule is, if you do not specify which class you want to inherit from, then you automatically are extending the class object. There's a built-in class called object that you automatically extend. Yeah?
What does object extend?
Well, okay. All but one class has to, one class is allowed not to have a superclass. That's object. Yeah. But any class you write has to inherit from something. Now, do you have any idea what methods you inherit from object automatically when you write any class? What's one method that every class you've written contained, whether you wrote it or not? Yeah?
Print, I think.
Not print, close. Yeah?
ToString.
ToString. Every class you've ever created, there's been a ToString method. And what does that ToString method do? If you create a class if you create an object of one of your classes and call the ToString method, what string do you get back? Yeah?
Isn't it the memory location of the object?
Right, it's a weird little string. It's the class name and then maybe an @ sign and then the memory location. But what did you have to do if you didn't like what ToString did? You wrote your own ToString method to do something more interesting. What were you doing when you wrote a ToString method? You were overriding the one you inherited from object. So you've been doing this all along. You haven't realized it. Another method you inherit is equals. And the equals method by default, who knows what the equals method does by default? Yeah?
Doesn't it compare the references?
It compares the references. It does reference equality. If you want it to do something more interesting, you can override equals. We've never done that, but you can. Okay. Now, when you do inheritance, there's another neat feature. D is a subtype of B. So the derived class is a subtype of the superclass, the base class, and vice versa. B would be a supertype of D. And what that means is that you can always use a subtype anywhere the supertype is expected. So if you have a variable of type B, you can store a variable of type D into that variable. You can store an object of type D into X. If you have a method that expects an object of type B, you can pass a D object to it. If you have a method that's supposed to return a B object, you can return a D object. Now, why does that work? I mean, wouldn't the programmer get upset if they thought X was an object of type B, but instead it was an object of type D? Wouldn't something go wrong? What could go wrong? What goes wrong if a variable contains an object you didn't expect and you try to invoke a method on it? What could go wrong? Yeah?
The method might be undefined.
The method might be undefined. Can that happen here? Is there any method you can run on a B that you can't run on a D object? Yeah?
But since you're running a D object instead of a B object, and B object, I mean the D object has more methods than, and more variables, excuse me, then wouldn't it be undefined because, well, okay, well, let me put it this way. So so D will have all of B's variables. So if
Well,
D had
the variables are private, so we don't talk about that. All that matters are the public methods.
Okay, the methods. So D has B's methods, method 1 and method 2, but it also has its own method, method 3. So if you pass a D object to something we're expecting a B object, then how is it going to know what to do with the method 3?
Okay, so let me paraphrase. There are going to be some methods you expect to be able to run on X, namely the ones defined in the class B. But won't all those methods be available on an object of type D? How do you know that any method you're expecting to run on a B exists in D? How do you know?
Well, that's the point.
Yeah. Right, you inherit all the methods from D, from B. So D automatically has all the methods defined in B, plus more.
So that wasn't my question, so I'm talking about the plus more.
Okay, so is the plus more a problem? Right, if you think you have a B object, you're not going to worry about the extra methods. You're just going to call the ones you think a B object has, which a D object does. Now let's turn it around. If I declare a variable of type D, can I store a variable of type B into it? No, because that B object has fewer methods than I'm expecting for D. So it's not symmetrical. Okay? Just a couple more pieces of slides, and then we'll take a break and look at code. So on the left, I have public class B, the base class. It has two instance variables and a constructor. So you don't inherit constructors. You have to provide your own. Furthermore, the first thing that every constructor has to do is call a constructor in the base class. No ifs, ands, or buts about it. You've got to call it. And so I've shown you one way of doing it. So I have a D constructor that takes an age as a parameter. This is how you call the base class constructor, which calls this thing and sets the age instance variable to whatever this is, and it sets the name to Jane. So this calls that constructor, and you're calling it to initialize the private instance variables that are specific to B. Then you can initialize your own instance variables. Now, I said that every class you've written has inherited. And I said that every constructor has to call a constructor in the base class, but you've never done that. How have you gotten away with never calling a base class constructor? In your case, an object constructor. Why have you never had to call an object constructor? Here's the answer. If you do not call a constructor in the base class, the compiler puts this one in for you. It calls the zero argument base class constructor. And so what was actually happening every time one of your constructors is called, the first thing it does is it calls the zero argument constructor from the object class. And it initializes its own instance variables if there are any. So essentially, the stuff in yellow is stuff you haven't realized you've been doing. You've been writing code like this. Actually, you have been extending object, and you have been, your constructors have called that base class constructor. Yeah?
I'm confused as to what's being like extended.
Okay, person extends the object class. It inherits all the methods from object.
What object?
Object is a class.
Oh.
It's a class built into Java. Yeah?
If you extend another class, say a third one from the second one, how super are we calling the first class, the base class?
Okay, so he's asking, suppose some other class extends person. So its constructor will have to call this constructor right here, which will in turn call the object constructor. Yeah?
Does object have any other constructors that actually take parameters, or?
The object just doesn't have any other, it just has one constructor that takes no parameters. Okay, so that finishes our high altitude look at inheritance. In the past, I've sort of I would dive into the code and stuff like this would come to the surface as we're talking. I decided this year to try to present it at first so that so you can see the framework everything is built around. So let's take a break, and then we'll start looking at some code examples. Let's get started again. Okay, here's what I want to do. I want to create a class called tip calculator. And when I run it, I want a GUI window to show up. And I want to be able to enter how much I spent on a meal and what percentage of tip I want to give, and to click a button and get the tip I need to add. Or maybe we'll have it added to the bill and tell the total bill. Okay, so a simple GUI application. And the reason I'm talking about GUIs at the same time I'm talking about polymorphism is that it just provides a great example for polymorphism, for the power of polymorphism. So let's see what I've got written here. Right now my tip calculator just has a constructor that does nothing. And so if I run this thing, the program ends really quickly. It's just a class with an empty constructor. So we need to do something different. Now I want to say something about this and then I won't talk about it again. That's a little bit of magic that you need to do to launch a GUI application. And I've given you lots of GUIs and they've all have the same main. That's just saying, run this code on the GUI event thread, whatever that is. We'll talk about the GUI event thread later. So this is just a bit of magic I don't care to explain. I will say that this thing here is called a lambda. And the way to read this is it's a method. This is a way of writing a method that takes no parameters, and this is what it does. When you call it, it calls the tip calculator constructor. But it's done this way because it has to be called by some other part of Java. So I'll leave it at that. That's not what I'm interested in talking about. I'm interested in talking about the tip calculator class. Now, a tip calculator, how is a tip calculator the same or different from any other GUI application you've ever seen? Graphical user interface. How is it different from Connect 4? How is it the same as Connect 4? How is it the same and different as the code I gave you that helped you draw the graphs? Do they have anything in common? Yeah? Say a little louder. Said it inputs text instead of just clicking on buttons. Well, I guess what I'm after is sort of at the low level of programming. What do they have in common? Yeah?
Do they all show things on the screen?
Yeah, they all are windows, right? They're all windows that pop up. So the way I'm going to think about a tip calculator is like any old program that pops up a window. It's like any old window-based graphical window. There are going to be some differences. And that's a case where I could use inheritance. I can say a tip calculator. So when you do inheritance, you're saying I want this new class to be just like the old class, but with some additional capabilities, maybe. And it turns out that what I want the tip calculator to be like is something called a J-frame. So a J-frame is basically a class that is, when you run it and make it visible, you see a window on the screen. So I want a tip calculator to be a kind of J-frame. So now that I've done that, I've added that little bit of code. How is tip calculator, how is the class any different? What did I get by saying tip calculator extends J-frame? Yeah?
All of J-frame's public methods.
Right, I just inherited all of J-frame's public methods. Okay? As if I had defined them in here. And one of those methods, let me run the program again, because now we're running a J-frame. So I run it, and nothing much happens. That's because I need to make, the J-frame starts out life invisible, so I need to make my tip calculator visible. And it turns out there's a method. We can look at all the methods I've inherited. So you probably can't read the list back there, but these are all methods that I inherited from J-frame. Yeah?
So does importing it, like at the very top, not do the same thing as...
No, importing doesn't do it. Now, I could do this. I could declare a J-frame here. And those same methods are attached to F. But by inheriting, I get those methods. Those methods are now tip calculator methods. And there are two ways to do this example. I could have done it without inheritance by doing something like declaring a J-frame and going from there. But I wanted to show you inheritance. So I I have inherited, one of the methods I've inherited is set visible. And I need to say make it visible. And of course the this is optional.
I think his question was, what's the difference in importing it at the top or doing the extends?
Okay, so another question would be, what's the difference between saying extends here and saying import up there? Okay, well, import just says it's okay to use this class in this file. So if I took that import out, I've got an error here. I still have to even use the word JFrame, I have to do an import. Okay, so I've just changed my tip calculator to call its set visible method. Why does the tip calculator have a set visible method? I did not implement one. Because a JFrame, a tip calculator is also a JFrame. And a JFrame has a set visible method. Now if I run it, a window pops up. It's not a very interesting window. I can resize it. I can move it around. You notice the program is still running. And when I X out of it, the program will stop. You can't see I'm in the wrong place here. So there's, oh, it didn't stop.
Yeah.
Yeah. So even though I closed the window, the program is still running. So I'm going to stop it manually. We need to do something about that. But just by saying that a tip calculator is a JFrame plus whatever I care to add. I can add new methods down here if I want. I inherit all those methods and I can use them. Okay, so let's see what else we can do. I'd like there to be a title. So there's a set title method we inherited, and I'll just say tip calculator. Calculator. Okay, so I'm just calling that inherited method. And you can see up here at the top it says tip calculator. Okay, so now my tip calculator has a set title method. It might be nice to have it come up as something other than as small as possible. So it turns out there's a set preferred size method. And did I do that right? Set preferred size. And it wants what's called a dimension. So I have to create a dimension object to pass to it. And I'm going to say I want it to be 300 by 400. And I have to import that class. So now when I run it, I've got to be sure to kill it, the old one. Now I'll run it.
I think it's just set size.
Try that. Okay. Pack is a method you sort of have to call to tell it to really lay it out the way you want it to be laid out. So now we've got this class, which I run it, and good. Looks like it's supposed to, it's a starting point. We can at least bring up a window. And notice I didn't have to do much to be able to do that. I just said tip calculator is a kind of JFrame. And I can call JFrame methods as if they were tip calculator methods, which in a sense they are. Okay? I'm going to change this slightly. The last thing I usually do is set up things and then make it visible. Now I don't like the fact that it doesn't, when I X out of the thing, it doesn't terminate. So I've got a bunch back there. There's a bunch I haven't. So I went back and killed a bunch of ones I hadn't killed when I was in my office, I guess. So there's one more thing we can call. It's like set default close operation. And I need to set it to exit on close. Okay, so by making that small change to my window, I run it, I X out of it, and the program ends. Okay, now we can start actually making it look different, making it a tip calculator. So What do you suppose we need to do to make it, to have it contain buttons and whatever? Just conceptually, you don't know the method names. Yeah?
Make a button.
Okay, we probably got to make a button. So it turns out there's a class called JButton. We can do that. We can say JButton. So we can create a JButton object, and we'll call it calculate. First we need to import JButton. And then we need to do something like I'll have to show you that later. So we create a button object. We need to create everything that shows up in the GUI is an object. So what will we need besides a calculate button? Yeah?
We need a text box.
Right, we need some sort of box where you enter the total, not the total, your check. Okay? So let's create, that's called a JText field. And we'll call that check amount. And I think we can make it a certain width. I'll make it width 20, whatever that means. And we'll import JText field. What else are we going to need? Besides a place to enter the check amount and a place to enter and a place to click. Yeah?
I have a question. How come we have to keep on importing all these things? I thought it was already in the JFrame.
Yeah.
No, the JFrame's a class. JText field's a different class.
Okay.
JButton's another class. You have to import the classes you use. Now, we could, if we wanted to, instead of importing all these things individually, I could just come up here and say, import everything from Swing. And then I wouldn't have to keep doing what I'm doing. Okay, what else do we need? Yeah? Preceding the text field should be what? So like directions maybe. Maybe we should have a label. We'll call it check amount label. And there's something called JLabel. Okay, now clearly we're going to need another box for the tip percentage and maybe a label for it, and then a box where the total is displayed and a label for it. But let's stop right now and see what we can, I mean right now we're creating these things, but if we run the program, they're not there. We somehow have to add them to that window we're popping up. Okay? So it turns out that there is a class called a JPanel, and what a JPanel can do is contain other things. So we'll just call this the panel. And what I'm going to do is create the panel, and then I'm going to say panel.add this. We're going to add the label to the panel. We're going to add the check amount to it. And we're going to add the button to it. So think of a panel as a piece of screen real estate that can contain other objects, other GUI objects. And the last thing we have to do is there's a method called set content pane. And we say, okay, display this panel as the content pane of the window. Okay, now this isn't anything I would have expected you to know, it's all detail. But if we do that much and run the program, okay, we have the beginnings of a GUI. We have a label that says check amount. We have a place where we can type stuff. And we have a calculate button that we could arrange to run code when we click on it. We haven't done that yet. Now, you look at this, can you think of any, besides adding functionality and adding more objects where you can enter more information, can you think of any way to improve this GUI? Yeah? Well, yeah, make it do something when you press calculate. Yeah?
Make it pop up in the middle instead of in the corner.
Maybe make it pop up somewhere other than in the corner. Yeah?
Add more buttons with suggested things.
Yeah, there's more stuff we could add. But what I'm after is, let's see what happens when I resize it. Okay, when I resize it, it displays like that. When I make it smaller, it sort of displays in a more sensible fashion. So what we're talking about, sort of the appearance that the thing has and what happens when you resize it is called layout. And layout's certainly necessary, but it's not very, it's nothing I want to talk about in lecture. It's a subject to the lab tomorrow, controlling where things appear in the GUI. But there's something else I want to talk to you about here. Let's look at what I did. I created a JPanel, whatever that is. I created 3 different types of objects, JLabel, JTextField, and JButton. And then I added all 3 of those things to panel. Now the add method here says it expects as its parameter a component. Add expects as its parameter a component. Yet I gave it a JLabel, a JTextField, and a JButton. Even though it says it wants a component. How was I able to do that? How do I get away with, with passing things of a different type? Yes?
Because they extend the component?
Because they extend the component class. Because of inheritance, due to inheritance, JLabel is a kind of component. It's a subtype of component. Check amount, or JTextField, is a kind of component. And JButton is a kind of component. So we can use those objects in places where components are expected. So that's inheritance at work right there. Okay? Let me look at JButton. In fact, let's go to a browser window. Okay? I want to look at some documentation. There's the JFrame class. Now, you may have never noticed this, but at the top of the class documentation, there's this chain. That's the inheritance hierarchy. Read it backwards. What's it say? JFrame extended what class? Frame. So a JFrame is a kind of frame. I didn't mean to click on it. A frame is a kind of window. A window is a kind of container. A container is a kind of component. And a component is a kind of object. So this is why I like to use Swing as an example of inheritance, because it's implemented using inheritance. So frame has a lot of methods. Some of those methods are common to all frame classes, and some are specific to JFrame. And this, and on up. Does JFrame has a two-string method? Do we know if JFrame has a two-string method? Yeah, it inherits ultimately from objects, so it has a two-string method. Okay, let's go look at JButton. Okay, so you can see a JButton is a kind of abstract button. An abstract button is a kind of JComponent, which is a kind of container, which is a kind of component. So great. It is a kind of component. That's why we could use it. But if we go back to the code, what will happen if I try to add a string to the panel? Why suggest that one? Why is it complaining about that? Yeah? A string is not a type of component. Yeah?
Is it not a J?
Right? So you can't pass any old thing to add. It has to be it either has to be a component or something that inherits from a component. So that won't fly. What do you think if I look at the declaration for set content pane? This right here. This is so when you create a J-frame, you have to give it something that is the thing it displays. Give it the thing that goes in between the lines of the window. What do you think it expects as a parameter? Right? If we look, it says it expects a container as a parameter, but we're giving it a JPanel. Why does that work?
Question.
Oh, okay. Why does that work? Yeah. Yeah. A JPanel is a kind of container. So a container is a component that can contain other things. So if I go look at JPanel here, we see a JPanel as a kind of J component, which is a kind of container. So it's okay to use. Stefan tells me we have an answer from online.
Question.
Question.
We have a question. Someone answered it, but I thought you might want to say it so everyone could hear it.
Okay.
A person asked, can you extend multiple classes? And somebody answered, not in the same subclass.
Okay. So that's a question I get sometimes. Can you inherit from more than one class? And the answer is no. You have to extend exactly one class. Now, next time we'll study something called interfaces that sort of let you inherit from multiple places. We'll see what that means. Okay, so another thing to wonder about is, besides, I could go and type in more things to display, more labels and panels, but that's more of the same. I could lay them out in a pleasing fashion, which is the subject of the lab tomorrow. But so what that really leads to make this work is we need to make this calculate button do something interesting. Okay? So when I click it, so suppose I had all the things I need. So I have two text boxes, two text fields where the total, the check amount and the tip percentage can be entered, and then another text box where I can display the answer. What would that calculate button need to do? Yeah? Okay, it would have to look in the check amount box and parse the number that's in there. So it would have to get the string, get the text out of the box and parse it into a double. It would have to do the same thing for the tip. Then it would have to do the calculation, and then it would have to take the result and store it as a string into another text field. None of that's very complicated. Now, of course, things will go wrong. People may enter things that aren't numbers, so you'd have to catch exceptions and display error message back to the user. But the fundamental unknown, you know how to do all that stuff. The fundamental unknown is, how do you get the button? How do you get the button to do something? So, given what we've talked about, what do you suppose is going to be the secret? What's going to be the key to making a button do something? Yeah?
Can you not write a method that creates a variable of some sort?
Well, no, you're right the first time. We're going to write a method.
That takes the J button.
And that method is going to be called, we're going to arrange for the method to be called when the calculate button is clicked. And the way we're going to do that is by overriding another method. So we're going to set things up, and then by overriding a method, we're going to arrange for the calculation to happen. And doing that will involve using interfaces, so I'm not going to start that today. I just want to do one more thing. Suppose there's something we don't like about the tip calculator. Suppose there's some method we want to change. Let's see. I've never tried this before. Oh, let's do this. Okay, so there's tip calculator. It calls the set title method. Let's override set title. Okay? So I'm just going to say public string, I think it's probably public void set title string s. So to override it, all you have to do is just implement it. Now let's make sure set title here is void and takes a string. So what would happen if I just left it at that? So I've overridden set title now, so it doesn't does nothing. So what difference will that make to my GUI, the fact that I've overridden that method? Okay, so when I run it, there's no title up there because obviously I overrode the method. So I can replace any method that I want to. Now that wasn't particularly useful way to override it. But sometimes you have a method, you just want to change the way it works just for the current class. And you do that by overriding. Now, one other thing you can do, suppose I'd spelled this wrong. Whatever. So now what will happen when I run it? Right? I did not override the method, so the title displays. So Java, late in its life, Java added an annotation called override. So it's optional. So but I recommend you use it. If you think you're overriding a method, put @override before it, declaring your intention. You're saying, I intend to override a method here. And what do you suppose that error message is going to say? It's going to say, there is no method by that name that can be overridden. That tells you made a mistake. So then you can fix the mistake. If you don't do the annotation, you won't be told when you've made a mistake like that. So the annotation is not required, but it's useful. Okay? So we'll continue along with this next time, trying to understand more about inheritance and subtyping.